Hi, this is Raghu from NIQC. Today I am here because of NIQC International, where I am doing Lean Six Sigma Black Belt certification course. Also, I am uploading this video as I am participating in DN Corporation Business Excellence Awards over 2020 year in popularity round. So I am requesting you all, please do like, share, comment, and subscribe. Before going to my project, in any manufacturing industry, do you accept the rejection which is going out of the target? Answer is no. As a being quality professional, we have been given some of the targets or objectives which are linked to our business strategies and goals. In those objectives, the main and key objective is our internal rejection should be always within the target. But we found that our machine shop internal rejection is going out of the target and which is continuing. Due to this, the cost impact on the business is around 30 lakhs per annum, which is a very huge amount. Also, the machine shop is running with different models. It was a very difficult task to us on which model, on which cause, on what solution we have to develop for the defect. So in this situation, we have decided to take a project on our internal rejection, where we can reduce our internal rejection and meet within the target. Hence, we have selected this project through voice of the business and voice of our process. We will have a complete details in the project slides. Let us move on to project PPT. Hi, welcome to our project. As I said, we have taken a project as to reduce internal rejection of machine shop division at Hyderabad plant location. We have used a methodology called DMAT, where which is a driven quality strategy, right, to improve our processes, and which is integral part of our Six Sigma initiative. It consists of 5 pages: define, measure, analyze, improve, and control. In define phase, we have defined the problem. In measure, we have measure our process performance. In analyze phase, we have determined the root causes of variation or defect generation, and we have identified the root causes. In improve phase, we have established the addressing the root causes, where we have did a pilot batch run to know the improvement progress, whether it is improved or not. In the control phase, we have sustained the improvement by developing a documentation like control charts, process MPPs, SOPs, etc. in the system. Come to define phase. We have defined here a project snapshot, where our all team members are with clear responsibilities are mentioned over here, so that there is no ambiguity throughout the project execution. We have defined the project order, the main elements, which are business case, problem statement, goal statement, project scope, financial benefits, and project milestones. We have studied the SIPOC analysis, where it will give the complete process information about from our input raw material to customer, that is output. We have a complete information of process here, and we have made a communication plan how the team members is communicated through different channels in the during the project execution, like our team tollgate members, mentors, and resources. We have defined our process map. Generally, for our machining process, the process is you know, there is from the receipt of castings to up to dispatch. It's a general process, and we have defined a one of the part how it will go in the processes, is which is having a detailed process map for the one part from receive to dispatch. We have defined project team, which is army, which is a basically a cap tool where our team is more uh, clear about their responsibilities, which was defined in the system. It means wherever, depending upon the phases, wherever the A for approval, R for resources, M for member, and I for interested parties. Wherever responsible for that phase, we will keep informed the project team, and we have recorded here. So at the end of uh, define, we have made the summary and status it completed. We have done the stakeholder analysis too, uh, because during the define phase, who all the members were interested to do the project, which can be known by here itself, and the other persons who are not supporting can be known, and we can make them to convince and take on the same form. So that here we have the stakeholder analysis also, for which only two members are moderately supportive because of their other projects, because of they have engaged in other projects. Yeah, we have finally we have did the sign off with 12 get members after completing of defined phase. Coming to major phase, in major phase normally we have to measure our process performance by by brainstorming the causes. What are the uh, causes, that means excess contributing for our internal rejection, and we have plotted all these causes in a fishbone analysis, so that where man, machine, material, and method is explaining about here, the effect is internal rejection, right? We have did the prioritization control impact matrix, where the causes were in control or out of control. What is the impact, and whether it is a high or low, and based on that we have collection plan for data, how the system is creating in the processes, different processes. After that, we have done the capability test, whether the process, the existing process is capability or not, capable or not. Based on that, in the major phase also, we have did the stakeholder analysis. In the earlier phase, the two members which are moderately supporters, now they are strongly support on this phase, so that they are encouraged. In the major phase, we have did the summary, after completion of all the actions, we have did the sign off with toll gate members. And coming to analyze phase, during analyze phase, we here here we have selected top 5 running models, right? That is, these are the parts, and these are the months, how many produced, how many rejected, and what is the rejection percentage for each part for last 4 months. Here we could able to see here the one part which is contributing more rejections from last 4 months. Due to this, the overall rejection percentage is out of the target, that is 0.8. And also this rejection, one rejection which is contributing 68% over the total cost of poor quality. You see here, if I do the Pareto chart, this gearbox where it is contributing here 20 numbers, which is more compared to other models, which is highest. So the inference of this, it was observed that the gearbox is contributing more rejection, that is 1.3 against the target of 0.5, and also the rejection cost is 68% of total CUPQ cost, which is highest from last 4 months. Also, we have analyzed now defect wise why the gearbox is getting rejected, what are the defects contributing for rejection, and we have taken the data and we have analyzed that one of the defect is contributing 50%, for which you know it is 0.6% is the total percentage in 1.3. So we have plotted the defect wise Pareto chart here, and we got this bore position out is the major issue in our system, which has to be eliminated on barcode basis. Yeah, coming to drawing requirement in the analysis, why is the bore positioning out? What is that bore positioning is out? Why is defective produced? The bore position out is meant that this is the requirement here. Here is the bore. This is having 250 diameter with respect to datums A, E, and D. Okay, this bore should be located within 0.5 is maximum. This is called position, right? Also, from the customer point of view, it's a static parameter. Actually, the bore is right now the rejection is saying like this, where the bore is shifting from center to other location. So the center wherever it has to be there, but it is getting shifted, and also these datums, with respect to these datums, the center position is changing every time. We have the probable causes, and we have validated through Gamba in the shop floor, and found that there are three main X's which are contributing this rejection. These are the list of proposed potential X's, where in this analysis phase we have did the stakeholder analysis, then and summary, and we have sign up. Coming to improve phase, in the improve phase, the proposed X's we have verified and tested, found that these are the main causes for the defect generation. So we have again on the control impact matrix prioritization tool, we have plotted this, where we found that this mechanical fixture issue, where it is giving more variation during bore machining and found that this we have to take actions on fixture point of view. So again, we have done the brainstorming by gathering production and quality teams. We have got 10 ideas from them. For 10 ideas, we have been multi-voting, and we have the 1 point which has got more score. That means on this we have to work and take action. So on this, the 10th point, robust design of new fixture to ensure parts should not distort while machining, got 42 marks. For this idea, we have discussed with supplier. So he was suggested to go for hydraulic fixture, where we can meet the quality as per the requirement. Immediately they have submitted code for that fixtures manufacturing. The cost was 19 lakhs. After taking the approval of management, they have manufactured and supplied to us. After immediate supplying, we have taken these fixtures into the manufacturing, and we have did a pilot batch model running. See here, these are hydraulic fixtures, where it is having dials and automatic lamp system, so that the part wherever datums are required are defined in this fixture, so that it doesn't have any manual interruptions. It will automatically sit in the fixture and align. After that, it will clamp during bore machining. The bore position out, which is talking about in our project, this is the bore, where by locating in this fixture, we will perform this bore machining, so that the bore position with respect to all the datum will be within the specification. In the improve phase, we have run the pilot batch, found that near about 136 numbers found okay without any rejections. In the full scale implementation also we have monitored from November to July, where we have taken action here. From March we don't have find any rejection. That means in the gearbox we have got a rejection percentage is 0.2, and the overall, the rejection was reduced to 0.2. Inferences: after full scale implementation we have reduced the gearbox rejection percentage is from 1.3 to 0.2, and overall rejection was reduced from 0.8 to 0.2 against the target of 0.5. We have plotted this improvement results, before and after. This is the area where the before was project. This is the area after the project completion. We have done the stakeholder analysis, summary, and toll-gate sign-off. In the control phase, normally we have done the cost-benefit analysis, and here some of the investments are mentioned over here, and the loss, especially before the project was 32 lakhs, right? After the benefit is we have recorded, we don't have any rejection for last 8 months. So total saving in the rejection is 31 lakhs per annum. That means per month is 2 lakhs 63,658. This improvement process we have, we have to be sustained. That means we have to do some documentation and need to hand over to management. So we have made a control plan by mentioning these fixtures in the control plan, by allocating a fixture number. The process MPP we have developed and hand over to project to the production. We have did the stakeholder analysis, summary, sign off. This is all about our project. Thank you. Any questions?